Hello there, Precalc students. This is Mr. Kashi again. This will be our last video of 9.3 on probability. We've covered a lot of different concepts. Our last one that we're going to cover here is conditional probability. We're going to go through a couple of examples as well. Conditional probability contains a condition that may limit the sample space for an event. So conditional might mean that if we're talking about students in a classroom, we could talk about all the students, or we could just talk about the male students, or we could talk about just the students wearing jeans, or then you could even get even more precise in talking about the male students that are wearing jeans. And so those would be the conditions that are being put on that probability. There is a probability formula that we will be using. And that formula, starts out with this. This is read as the probability of event B given event A. So basically, what is the probability of B happening if A happens first? So we're going to use the formula. Probability of B given A is the probability of A and B happening divided by the probability of A. And we're going to talk about that in kind of a different context, but just so that you know that that vertical line means that it's given. So we're calculating this given that that happened. So here's a table that shows the results of a class survey. Use the results to find the conditional probabilities of the given events. Now, when there's more than one question, I think it is always beneficial to add some of the columns and the rows up. So if you're talking about just males, we'd have 7 plus 8. We'd have 15 males, and females we would have 13. And then tallying up the column, there'd be 14 that said yes, and there'd be 14 that said no, which means that we have a total of 28. And so the male and the female and the yes, did they do household chores last night or not? Those are the conditions that we're putting on this. So here, the probability of did they do a chore? Well, there are 14 that said yes out of the total of 28. You could reduce that to 1/2, or that would be 0.5 or 50%. So here it was 50-50. But now they're putting some conditions on it. So B is, what's the probability that they did a chore given that they're male? Well, in this case, we're only talking about the males, so we only have 15 to choose from. And did they do a chore? Well, there was 7 of them that did. So now we're talking about 7 out of 15. We're not talking about the females at all. We're putting the condition on of did they do a chore given that they're male. And once you divide that out, you get just under 50%, 0.46, and it's actually 6 repeating. So between 46 and 47%. Then the next question is probability that they did not do a chore given that they're female. So in this case, we're just talking about the female, so 13 would be our total number that we have. And the percent that did not do a chore would have been 6. So 6 out of 13, you divide that out, and you get 0.4615. So hopefully you understand how these different categories, male, female, yes or no, they put different conditions on our probabilities, and that changes the outcome. So just another example here with a little bit more real world example of talking about municipal waste, and this is all measured in millions of tons. So the table below shows the amount of waste in millions of tons in the U.S. Use the table to find the conditional probabilities of the given events. So we have 3 questions here. I still find it easier to add up the rows and the columns. So we'd be adding up paper, metal, glass, plastic, and other. We'd be doing that across as rows, and we'd be doing then the columns of recycled and not recycled. So I went ahead and did that. You can do it yourself if you'd prefer. This is 81.8, and we have 18.2 for metal. We have 12.5 for glass, 25.4 for plastic, and 91.3 for other. And then if we were to add up the recycled, that would get to a total of 68. And then for not recycled, we would have 161.2. So I find it easier just to have those numbers taken care of. We might not use all of the numbers, but it's just easier if they're just there. And you don't have to worry about calculating them as you go. This would come out to be a total of 229.2, and that is in millions of tons. So if we go to our problem A, if a sample of waste is randomly selected, what is the probability that it is recycled metal? Well, recycled metal would just be the 6.3. So we're taking one stat out of the whole table, but we're talking about all of the waste. And so our total waste would be the 229.2, and we're doing 6.3. And that divided out would be a 0.0275 or 2.75%. So now down to letter B. If a sample of recycled waste is randomly chosen, find the probability that it is paper. Well, here we have 2 conditions. It's recycled waste. So recycled waste, our total would be 68. Because we're just talking, that's the condition that's put on, is just recycled waste. And then chosen that it's paper. Well, paper is 36.7 of the recycled side. And so here we're talking, when we divide that out, 0.5397, just under 54%, given that it's recycled waste that we're talking about. And then our last one here, if a random sample of glass is chosen, find the probability that it is not recycled. So now we're just talking about glass. So here, if you go up to your table, we're just talking about glass right there, which is a total of 12.5. So our denominator, our total, would be 12.5. And then they're asking that it is not recycled. Well, it's 10.1. So then you do 10.1 divided by 12.5, and that gives us a 0.8080. So just over 80% of glass is not recycled. And so hopefully you can see with this table and the calculations that we did how conditions can be put on a set of data to create different statistics about it.